Assalamualaikum and selamat sejahtera survivors. I am Nafika Shazana from Section 1, Group 7. Today our group will present about the Geotechnics project. This is our group member, which is Nur Alia Adriana, Nur Alia Diana, Nur Sofia Iwayu, Siti Maliha and Nafika Shazana. A geotechnical project could run into a number of problems. Some of these issues might be resolved to create a framework that is actually safe, while others might force the project's complete cancellation. Everything depends on the nature and severity of the issue. Before beginning any building, it is crucial that we conduct a true geotechnical survey to prevent future issues. But if we are constructing a business or facility with more than 2 levels, this becomes even more crucial. Due to the fact that not all construction sites are level, the surrounding slope must be throughout about. Our site may be destroyed if slope consisting of several types of soil or rock were to collapse. Some contractors will build retaining walls to solve the issue, but choosing the appropriate style of retaining will require knowledge of the slope group.
Hi, my name is Nur Alia Adriana binti Muhammad Faizal. My metric number is AF210060. So now I'm going to present about the soil characteristic of peat soil. So what is a peat soil? Peat soil is usually identified as one of the most problematic soils in geotechnical engineering, and this type of soil are considered as organic soil. So peat soil is formed over thousands of years from decayed organic components created in wet or water areas that are under suitable topography and climate circumstance, such as in Malaysia. They are usually in Malaysia, and it is obtained from synthetically produced and fossil plants. So what is the characteristic of this peat soil? So this peat soil is usually a dark reddish brown to black in color that are frequently located in various thickness in restricted location, and they have posture strength, and they exhibit considerable compressive deformation, which can frequently cause problem when building work is performed on the soil. Other than that, it has many unique characteristics such as high moisture content, low bulk density, high compressibility, soft spongy substrate, high organic content, low shear strength, low bearing capacity, and high acidity or low pH. And it will be very threatening to build on construction on this soil. So now, is there any peat soil in Malaysia? Yes, they are definitely have a peat soil in Malaysia. And for your information, there are a lot in Sarawak, in Sabah, and in Peninsular Malaysia. So the highest percentage of peat soil in Malaysia is in Sarawak, which is about 1 million hectares in Sarawak. That is very a lot. So Malaysia, there are functions of the peatlands in Malaysia, such as they are protecting groundwater, controlling and decreasing flood impacts, supplying fish, lumber, and other many more. So that's all from me. Thank you very much.
In this investigation, we have looked at the settled land that exists along Jalan Pesisir from Kampung Tamri to Asal Jaya, Kota Samarahan, Sarawak. As a common factor in geotechnical engineering, people in the Pesisir Asal Jaya want expansion to develop, thus lorries are needed to transport construction supplies. Additionally, there has damaged property because of how frequently lorries use the road in the Asal Jaya region. We can improve this issue in several ways. For instance, we can increase the depth of foundation due to the higher overburden pressure on soil at greater depths. The soil is more compacted. On the other hand, we also can drain the soil. The bearing capacity of the soil diminishes as soil water content rise. Due to the presence of water content, the bearing capacity of sand soil may be reduced by as much as 50%.
Hi and Assalamualaikum. My name is Siti Maliha binti Muhammad Amin from Group 7. I'm going to present about case study 2, which includes site investigation, topography map, drainage system, and geological setting. As shown below, this is a topography map of Kampung Tamri, Kota Samarahan, Sarawak. The catchment area for Kampung Tamri is situated at 1.5 north and 110 east. The altitude for the catchment area is 4.572 meter. It is a part of the Kuching district. Kampung Tamri has a tropical humid climate with low seasonal temperature change. The region's daytime temperature is 30 degrees Celsius and its typical nighttime temperature is 23 degrees Celsius. For drainage system, with a potential evaporation rate of 3.4 mm per year, the annual daily evaporation for Kuching, Sarawak is between 3 and 4 mm. Kampung Tamri in Kota Samarahan is located downstream on the embankment of the watershed, which has total area of 13.3 hectares. The watershed runoff travels downstream to the river Sungai Sabak, which eventually is 0.3 km upstream of the Batang Samarahan Bridge. The total of the main river basin in Sarawak is 40, with 74,650 population. Next, we move to geological setting. In the year of 1990, Lam Shia Keng, one of the geological survey Malaysia team for Kuching, Sarawak, has carried out a quaternary geological mapping in the Kota Samarahan area to obtain geological data for land use planning in the Kota Samarahan sub-regional center study area. Some quaternary sediments cover the whole research area. There are 2 sediment streams exposed in the area, which are floodplain deposits and polluted deposits. Both deposits are placed on top of bedrock or leftover soil from deltic or stranding deposits. If the polluted deposits are applied as the foundation level for construction, there will be significant issue because they are unsuitable for engineering projects. In the research area, additional geologic limitations include bank erosion, a lack of breathing supplies, and a deep foundation level. After that, we move to type of soil in Kota Samarahan, Sarawak, which includes clay, silt, sand, and peat. First, clay is a type of soil for hydrosilicate mineral particles that are less than 4 micrometers in diameter. Fine alumina and silica crystal can be found in clay. Clay typically contains silicon, oxygen, and aluminium, a type of element with numerous composition in the earth's crust. Clay is created when carbonic acid reacts with silica rock to weather A, while some clay is also created as the earth's interior heats up. When clay comes into touch with water, it becomes wet and sticks together when it is dry. Another form of soil that has a lot of alumina or very fine silica in it is clay soil. Then the second one is silt soil. Silt soil seems to have a high fertility rating and it is a light and light tolerant soil type. Medium-sized particles are affected by silt soil, which improve its ability to drain and hold moisture. The particles are small, easily compressible, and likely to wash away after rain. Alluvial soil is another name for silt soil. Rivers erode the soil, which then settles along their banks in plains. Near the banks of many rivers in where you typically find this kind of dirt. This kind of soil benefits in agriculture and it is very fertile, beneficial for plant growth. After that, sand. Sand is a found naturally granular substance made up of tiny rock and mineral fragments. When hard rock is exposed to the environment over time, it diminishes or breaks, resulting in huge pieces that are broken into smaller ones and carried away by the wind and air from their original accumulations, such as huts and beaches. River mine sand is a crucial component of construction, especially when mixing concrete, and it is highly sought after due to its distinctive qualities that cannot be replaced. And the last one is peat soil. Peat soil is a type of soil created over thousands of years from decayed organic components like sphagnum moss. Peat soil is a type of soil created over thousands of years from decomposed organic components. A large portion of the organic matter in peat soil comes from decomposing plant debris such as sphagnum, peat moss. In wetland habitats known as peatlands or peat bogs, peat soil gatherers. Bogs like this may be found all over Russia, Scotland, and Southeast Asia in nations like Malaysia and Indonesia. The majority of the peat soil in the US originates from Canadian peat bogs.
Hi, my name is Nur Ali Adriana binti Muhammad Faisal. So right now, after we decided that the peat soil in Sarawak has been our site investigation, we need to identify the article limit. So the PL cannot be determined for the peat even if they are in high humidification because peat produce a very low strength spongy fibrous strain. So as you can see from the table, that shows the Atterberg limit that we have found. But this concluded that Atterberg limit is actually not appropriate for the peat soil as they contain enormous amount of fiber content and it might affect the Atterberg limit as the penetration code cannot be molded. For the shear strength of the peat soil, we have considered that the peat soil is a very low strength as the value as stated at the table is 14.23 until 21.62 kPa and that are classified by the table of undrained shear strength range of soils. So after that, we need to identify the particle size distribution. As you can see, there are 4 materials that we use to identify the particle size distribution. Moving forward to the permeability, as we can see, right now we have tested for the first day, second day, and the third day, and then we compared it to the partially saturated to the fully saturated. Thus, this proven that the fact of they had the medium-low value of the permeability and reduced the active porosity inside the specimen of the peat soils. After that, we need to identify the compressibility of the peat soil. So, as you can see from the table, the value of Ca is going up as the concentration pressure is increased. As you can see, the range of the parameter of Cc per 1 plus EO is defined as compression ratio if the is in the range of more than 0.20. And then, after that, you can see that the law of compressibility of the peat soil are in the range of 0.02 to 0.04, which indicates the peat soils are lower. So, in this case, we have concluded that the peat soil are high secondary compressibility and they are very compressible. So, for the next one, we need to identify the soil classification for the peat soil. As we know that the peat soil is a very difficult soil to identify as they are the organic soil. So, they cannot be identified from the ASTM American standards and the British standard. They can be classified by the other classification system by using the ash content method. So, the peat soil was referred to the highly organic soils, which include the peat, muck, and the other organic soil. After having the current issue that they cannot classify the peat soil, Malaysian soil classification system decided to make a new classification system for peat soil as the peat soil have a huge amount in Malaysia. Thus, the system MSCS defines the degree of humidification and the percentage of fiber content is the best way to classify the soil, as you can see from the table that they have to classify using the organic content and the degree of humidification.
Today, I would like to present correlation between physical properties and mechanical properties of peat soil. This correlation gained from SI data. Okay, first, when maximum dry density decrease, the liquid limit will increase. Next, when the organic content increase, the value of liquid limit, fiber content, optimum moisture content will increase. And then fiber content and organic content will decrease as the maximum dry density increase. And then the percentage of clay will increase when it has a lowest permeability. And then the liquid limit also will increase when the shear strength decrease. And last one, the liquid limit will increase when the permeability decrease. So that's all from me. Thank you.
Assalamualaikum and hi. My name is Nur binti Muhammad Salizan. Today I'm going to present the additional correlation that I got from article engineer. The first correlation is correlation of moisture content and liquid limit. Second correlation between plasticity index and liquid limit. Next correlation between physical and engineering properties. Fourth correlation between LLOMC and MDD. Next correlation between FC, GS and OC. Sixth correlation between UCS value. Seven correlation between UCS and liquid limit. Eight correlation between unconfined compression strength and organic content. Nine correlation between compression index and liquid limit. And the last one is compression of minimum organic layer thickness and minimum organic matter content for the soil surface. Next, I'm going to present the comparison of SI report and established correlation. For SI report, sample 1, for natural moisture content is 620.17 and 14. Meanwhile, for established correlation, for sample F1, we got 360.72. For sample M2, for SI report, for degree of decomposition is H5, which is larger than established correlation, that got H4. Meanwhile, for loss on ignition, for sample 3, SI report got 67.88. Meanwhile, sample M3 for established correlation is 85.67. Established correlation is larger for loss on ignition than SI report. That's all from me. Thank you.
And the last one is for conclusion. Peat lands play a significant role in Malaysia and offer a variety of priceless goods and services. Peat was once used for cooking and home heating, but its primary function today is as a source of fuel and energy. Peat has even been the predominant fuel in several countries. The majority of the nation use peat for energy, which is made into peat briquette. The total area of peat soil in Malaysia is about 2.6 million hectares, of which about 30% are in Peninsular Malaysia, over 80% in Sarawak, and 5% in Sabah. Thus, it represents a key issue for infrastructural projects since peat soils have inferior geotechnical qualities than different soils. And that's all from us. Thank you.